Hello, everyone. Today, I would like to talk to you about the network layer and the routing consideration. This talk is about the network layer. Network layer is located at the OSI layer number 3. As you can see here, and here's the physical layer and the data link layer. Data link layer is something that Wi-Fi, local area network, which uses MAC addresses, right? So, and the network layer is a very important function within the internet. It performs a routing. It also controls the congestion. And also a connection control. It can be a connectionless or connection oriented. Depends on how you want to, transmit it. And for the transfer layer, it hides the detail of a network. What does it mean? Is provides end-to-end reliability. Okay. So, and the flow control. It's very important to understand this 4 stack here. And the physical layer is basically, optical, is made for very fast transmission. Okay. And data link layer is basically considering you only care about the neighbor, one hop. Okay. It's not more than a one hop. It's only a one hop. That's more of a data link layer. And also a network layer is considered also, it's more than one hop. We're talking about 2 hop, 3 hop, 4 hop in that sense, okay? It's a multi-hop then you need a network layer. If you need to just send it to your neighbor, just one hop, you just need a data link. But if you need to send it to more than one hop, 2 hop, 3 hop, or 4 or 5 hop, you need a network layer. And transfer layer, you make sure whatever you're sending from your source, make sure that it has arrived safely at the destination. That's the function of a transfer layer. Okay, but in this talk, I'll be focusing on network layer. Let's take a look at a network layer, which is a very important layer. Uses network layer is where the IP, internet protocol, located at, right? Uses a service of data link layer and a reliable point-to-point transmission between the load. That's the function of a data link. It makes sure the point-to-point right next to the neighbor is able to deliver, reliably, safely to the neighbor. Okay. And it has a packet switching, which is a packet means that we're talking about the data for end-to-end connectivity is a function of network layer. Okay, it provides end-to-end delivery of the packets as a service to higher transfer layer, protocol. So transfer layer makes sure that whatever you're sending is make sure you rise, but the network layer as a functionality is that it makes sure one hop to another hop, multi-hop, make sure it's able to deliver toward the destination. The one thing that I want you to remember is that delivering packets, it can be done in 2 services: connectionless, connection-oriented service. Connectionless, it means it doesn't have to determine whether the destination exists or not. It just sends it. Can next hop take care of it? It doesn't care. Okay, connectionless means you just send it whether even though there's a destination address. You just send it to hope that the next door neighbor node be able to send it to. Eventually, you can get to the destination. But in connection-oriented means service is different from connectionless, totally the opposite. It goes verify, it goes multi-hop and verify where there's a destination that exists or not. Okay, and once it goes to a destination, it comes back with acknowledgement. Okay, come back with the acknowledgement. Then it starts sending the packet to the destination. Okay, that's a big difference, okay? But majority, when you think about internet, the internet, when you're downloading and things like that, it's mostly a connectionless, right? But connection oriented, like watching video and things like that. And those are the connection oriented services. Okay, so what are the mechanisms connection oriented? When you think about telephone, right? You got to make sure when you hang up, lift the phone, and when you dial, and what it does is make sure at the destination, make sure there's a person or device available is working properly. Then it comes back and try to make a connections. Okay. So, internet is mostly a connectionless service. Then establishes a managed connection through subnet. If it's a connection oriented, that's based on IP addresses. And I'm not sure we're going to be talking about in here or not, but okay. It determines the routes of the packet from sender to the destination. Remember, sender to destination must be a multi-hop. It's not a single hop. And it determines the route from packet from sender to the destination. Okay. And this is typically done, what they call is a source routing. Okay. The source node that determine the route to the destination need to have that. It needs to have more of a routing protocol. There's a routing protocol that needs to be, implemented. And I haven't talked about that yet, but the routing protocol is like having a map, okay, map of the city, a map of the location. So using the map, it can determine where the node needs to send the, packet to the next hub, so it can get to the destination. Okay. It exercises a congestion control to maintain network efficiency. During heavy traffic load. During a congestion, there are a lot of packet loss could occur. So make sure that congestion is manages how much traffic inject into the network. Okay. So all allow transport layer to send data from host to host without need to know the network detail. That's the function of the transport layer. It doesn't need to know the individual node. It needs to know that whatever is sending is arriving at the destination. Basically, when you talk about the TCP, is a typical transport layer. There's a UDP as a transport layer protocol. In a TCP, as it sends acknowledgement back. Once it received, acknowledgement is like a receipt. It's just sending it back to the source, make sure, indicating that the packet has arrived safely. Okay. So unlike other layers, for the network layer, what it needs is it shares the information between the node. Okay, what they call is a routing updates or sending periodic update. When there's an event, is send up the update. Hey, I'm here. There's a pinging. Periodic pingings occurs to make sure that I'm alive or is there. So no one needs to share that information among themselves to make a decision. The purpose of that is trying to make sure that every node has the same topology information, same map information, so that routing could be performed. Okay. So those are the network layer functionality, but there are some issues. So issues are, typically is routing, how to select the best route through the network. Routing could be unstable if there's a lot of traffic going in and out. Okay, and also the routing could be a problem when everybody uses the same link, particular link get to the destination, because that link has to be very popular or something. So selecting a best route has a different meaning. When you think about the Dijkstra algorithm or Bellman-Ford's algorithm, those algorithm, things like that, is to select the shortest path to the destination. Having a shorter path, that's not all good all the time, because having a shorter path and everybody uses the shortest path, and some of the link could be overused, and that causes traffic congestion, right? There's a congestion control. You don't want to have a route going to the same place, same route for everybody else, that causes congestion. Okay, so there's also about addressing, how to identify hosts and nodes. The IP addresses, as you know, is kind of somewhat limited, right? And that's one of the reasons they created IPv6. And nowadays, a lot of companies, they are not able to assign unique IP addresses. So they use network address translation called NAT to artificially assign temporarily IP addresses. And also, you guys, whenever you guys hook up to the internet, your IP address is more dynamic. Every time you hook up to the internet, your IP address changes, right? However, IP address is layer 3, right? Network layer. However, when you talk about the MAC address does not change. Your MAC address is like your name, right? So you don't change your name wherever you go. So wherever you take your device or wherever you go, MAC address does not change because it comes from a factory, right? But IP address change whenever you move the node, the device. IP address change. IP address, you could think of it as your home address. When you move to a different house, right? Your IP address change. I mean, your address changes, just like IP address. Okay. Another thing is challenging the internetworking. How to deliver packets, across the network of different network, because now the network is managed by a different company, okay, or different country. So whenever you send a packet, you go through different country and different network. So it needs to be able to internetwork one another. That can be a very challenging, because some of the network have a different requirement, okay? So those are the network issue. And also, I'll talk to you about the routing consideration here. Routing is very important. And that's why there's a routing updates exchange between the node, like I mentioned before, because every single node needs to have same topology information. To do that, the routing needs to be exchanged. So routing determines a path through the network, more than one path possible, okay? Sometimes they don't have a choice, but sometimes there are more than one path. Selecting a path depends on different priority, but typically now the internet is usually uses Dijkstra algorithm and finds the shortest path, okay? So I mentioned about connection-oriented and connection-less. For connection-oriented service, requires computation setup of the path. That's how I mentioned before. It requires computation. That's why it needs to have a routing information exchange between the node. Using those information creates a topology map. Using the topology, you can calculate the the path from source to destination. Okay, so connection oriented, when you first send it, since you need to verify, make sure the other side is valid or not. So it takes longer, right? It takes longer to, set up. So for the connectionless one, you just send it. You start fast, but the connection oriented later on, what do you call it? Catch up. Okay. And the connection oriented is more reliable. Okay. For the routing during the set, host can specify requirement. Do you want the route with the maximum bandwidth? What's the requirement for the delay? What's the maximum delay? You have network has a chance to reject or reserve resources for the connection. How much bandwidth you need to utilize. That's the one of the tricky thing is how much bandwidth is enough, because traffic tends to be very dynamic. It doesn't stay at the same level. Sometimes it uses a lot. For example, it uses a lot like 9 a.m., 10 a.m., 11 when there's a lot of businesses going on, right? It kind of slows down around noon because everybody take lunch. Around 1 o'clock, 1:30 or 2 o'clock, it starts pick up the traffic until 5 o'clock. So what I'm saying is, network bandwidth uses does not, stay the same. It goes up and down multiple times. Okay, so once you allocate enough bandwidth, maximum delay, what's the maximum delay you need to have? So you need to make sure that the network can allocate that much bandwidth and make sure it's able to be able to deal, provide a connection with the, deliver with minimum delay as possible. Because of each node along the route, it knows which node to forward to, because it has a total, route information. So it knows where it needs to go to. Okay. Okay, packet with the same virtual circuit maintains a sequential order. And the vulnerable is node to link failure. It has the path already, determined, is traveling there. What if there's a link failure occurs? There's sometimes no failure occurs. So link failure is sometimes link is cut off. Okay. Sometimes no malfunction. Sometimes node does not work properly. Okay, then in that case, that's a big problem. Okay. So I'll talk about the connection oriented. I'll talk about that here. Let's talk about the more of a connectionless path for each packet is computed independently. There's no setup, no disconnect phase. When you talk about the telephony, right, it needs to set up first, then it sends the packet. But in this case, it doesn't set up. It just send it. Hope that the next node can handle it. Eventually, you will get to the destination. Okay, so no setup path is performed. There's no reservation, and basically uses as the best effort type for network service. This is when you talk about when the traffic requires bandwidth, efficiency, or enough bandwidth for video and audio. You need to have some allocations reserved. Having connectionless can be very challenging to provide a good quality of service. Okay. More processing, nodes makes a routing decision in each whenever you receives the packet. Make a decision in which node it needs to send it to the next. Okay. So another thing is that it says the datagram arrive at destination out of original sequence. What this means is that once you send the packets, you send the packet 1, 2, 3, 4. When you arrive, it could arrive in 2, 1, 4, 5, 3, or something like that, because it's not connection oriented, which means it has not set the path. It's connectionless, so it goes a lot of different direction, right? A lot of different direction, and eventually you arrive at the destination, because some packet could take a longer route compared to the other packet. Okay. So, it's a more reliable, adapted to failure. In this case is when something link failure or, no failure occurs, eventually it figures it out and go back to the normal, but it takes a long time to do that. It's more than a minute. Okay. Okay. So let's move on. So when you talk about the, routing algorithm, routing algorithm is select the best route according to some of the criteria. Criteria that like stuff that I mentioned is do you need a bigger bandwidth? What's your delay? And that's what the internet service, what they call is a SLA, a service level agreement. And requires information from other nodes. They exchange it cooperatively, complicated by failure and congestion. Because nature of the internet is not stable. It does have some failure, has a congestion. That makes it really challenging to provide good quality of service. Okay, it depends on what routing algorithm you select. It may require you to have a connection-oriented service once you have a routing always selected. So there are different routing algorithms. There's a flooding, there's deflection routing, random routing, source routing. It's typically source routing is what's being used in most cases in a Dijkstra algorithm, Bellman-Ford. And there's a least cost routing is which utilizes the least amount of resources. Okay. Okay, let's move on. For the routing is where are decisions made, right? Sometimes there are, different way of doing it. Each node, hop by hop routing. This is more of a connectionless, routing. The centralized routing is one node provide routing for all of the rest of the node, but this one has some. It's a good thing, but it has a more has a scalability issues. One node making all the decisions. Okay, has a scalability. Source node is a more of an independent way of doing it. This is the most popular one. So whatever the node is trying to send the packets, it makes its own routing beginning to end. Okay, source routing, like I said before, you can have that if everybody have the same topology. To do that, you need to send routing updates between the node. Okay. So you got to determine which one that who makes the decision. So is a decision made per packet, like a data graph, is connectionless. The per session is, for example, you're calling someone or you established service with the one entity or node somewhere, one service, any of the service you want to add, it does more of a virtual circuit. So you need to make a decision. Is it going to be more of a data graph or the virtual circuit? Okay. So there's more, different routing that you have to, select. Is that going to be a more static? or more of adapted. Adapted means that if there's traffic continually changing, you keep changing the route. Okay. Or random is I would not recommend random is any route, whatever the route available. Okay. So another thing is in the route, how much information is available. You got to determine then is no information available. Is a local, each node is its own information, it doesn't share. Okay, and you have information about adjacent node or on node for centralized. Typically in the network where point is no node should keep own information, does not share. The thing is that this is more of a teamwork to send the packet from source to destination. You need to be able to share all the information between the node. Okay. So it's not good to just keep it for own node. So what are the performance criteria? Number of hops, how many hops? Is there a hop limitation? Is a cost per link? Do you want the least cost? How much is the delay, throughput, and things like that. Okay. So when you have a routing table, typically more likely it can perform source routing, and also it needs to determine how to get from source to destination. Connection oriented is the most reliable, more predictable way, okay, to send the packet to the destination. If you need a quality of service, the service you need is a very, how should I say, reliable, dependent, then I recommend to use more of a virtual circuit, which is a connection oriented. Okay, so to do this routing table, there are a lot of control messages exchanged between the node. If there's instability between the nodes. Okay, routing table is updated during connection setup phase. All packets same version follow the same route. It doesn't take it's like the route is pinned. Okay, it's like pinned. So routing table incoming link. What is it incoming? Virtual ID. What is the outgoing link? And there's a virtual circuit ID. There's the advantages of no routing decision per packet. It doesn't have to think about it, just uses those routing table to send it one node to another. Okay. So disadvantage is that if there's a link or no failure occurs, you bring down the whole virtual circuit. Okay. And here's an example. Okay. This this is a setup. Because of each node has its own topology information, it's able to set up the connection-oriented route. It establishes something routing like this. What is the incoming link? Virtual circuit, okay, X1. Then it directly send it to the outgoing link, virtual circuit Y1. So it doesn't have to think, you just have to just grab it and send it out to the link one after another. Okay, it's very fast. Okay, so when you talk about the datagram connectionless, totally opposite compared to connection oriented. It's not established route. In this case, a route for each packet is decided independently. Okay, and routing table, destination, outgoing link, and next node, cost. Those are the parameters included in the table. So given destination, choose the outgoing link based upon some cost measure. It could be a distance, it could be a delay, or it could be a number of different things. And one good thing is since route is not pinned, it's more adaptable to the changing network condition. That's one of the good things. Okay, so disadvantage is more processing per packet. So it has to think a lot. It has to process per packet. When you think about the connection link, it doesn't have to either come in one link to send it out the outlink, right? So in this case, table is totally different. So once you receive the packet, it determines what's the destination. Okay, its destination is going A. There's a number of outlink, 1, 2, 3, 4, whatever, and here's the cost. Sometimes it takes the minimal cost. You could, but when you take the minimal cost, everybody take the minimum cost. It could be a very congested, right? So that could be really a big problem. Okay. So having a more of a connection oriented connection less. I think what I mentioned before is a routing protocol plays a very important role. Okay. So is a routing is static. Once it's set up, it does not change. Dynamic means it keeps changing, depends on the network. So routing protocol is selection of the routing protocol is very important. Depends on, do you want a static? Do you need a dynamic? Do you need to change the route? Depends on how table, changes. Okay. And also, how often do you need to send the updated information to the neighbor? It's more frequent you send it, it becomes more accurate, right? More accurate, more table becomes more accurate. But it has more overhead because its network is full of control messages all over, right? So you want to minimize the control message, but when you do that, the table does not become accurate. It can be outdated, right? So consistency is keep accurate same information all the node. So because the purpose of the having this routing updates, so make sure all the node has the consistent information. So you got to pick the routing protocol. You can perform things that you can do it, right? So level routing, a large network internet packet may travel within subnets in between the multiple. Subnet is a small clusters, like a cluster, network. So, within a company, there are multiple subnets. You could have a subnet for certain departments or, certain organization. And, you should have to, exchange pretty freely between the, within the subnets. So autonomous system or routing domains, subnetwork group or subnetwork under single administration. Let's see. Okay, so let's talk about the routing. Now nodes exchange routing information, make routing decision. Protocol is determined by administration. This is really outdated protocol. Routing information protocol, RIP, is outdated. You use that's one of the first routing protocol being used. It's not no longer being used, I don't think. And the OSPF is probably one of the most famous open source first shortest path first is widely used. There's different version of OSPF version 2, version 3. Some of the version has a quality of service built into it. Okay. So autonomous systems connect through exterior gateway. Autonomous system is you could have one subnet, one cluster. All those clusters are connected one another. That's the function of autonomous system. Okay. And between the autonomous systems, their communications is used based upon border gateway protocol. It's not OSPF. Yeah, OSPF is more for intra-domain routing, but BGP is more of autonomous between the border gateway protocol. Okay, so here's an example of it. Let's take a look at the layer routing. These are the different autonomous system, and intra means in. Okay, intra autonomous system routing means that there's a routing information is go between these nodes only. It stays within the autonomous system. Okay, so in that. And within there, you could think of it as using OSPF protocol. Okay, it just stays in there. But if you want to send a package to different autonomous systems, so autonomous system here, autonomous system there, in that case, you have to send it through. You see the thick line here. Inter autonomous system routing. This is more of a border gateway protocol. Okay, there's only one protocol. There's no other protocol. Border gateway protocol is the only protocol allow communication between the different autonomous systems. Okay. Okay, those are the different things. So within here, within the intra-autonomous system routing, you could have OSPF, there's a RIT protocol, there's ISIS protocol, different intra-domain. But for the autonomous system, routing here, it has only one protocol. That's more of a BGP protocol. Okay. So protocol. Okay, next thing is the routing algorithm. I would like to have another video created for this routing algorithm. And this is it for today. And thanks for listening about the networking and the routing and things like that. So let me start the share. Okay, please watch the next video regarding the routing protocol. Okay, thank you.